everybody. This is a joint talk, and I also realize we are both standing in between you and lunch, so we will try and keep this brief. 20 minutes. So feel free to interrupt us if we go beyond 20 minutes. We'll try and take questions, but maybe we'll make them offline. Okay, so today's talk, this is actually Avinash's talk. I'm gate crashing the talk. So talk today is not about us, but brief introduction. Both Avinash and I work at Platformatory. You can talk to us about better interests than stream processing. Anybody's interested in Bangalore, BMTC buses, etc. Avinash is an expert. I'm also an expert. I recommend everybody take BMTC buses. All right. So today's talk, we'll start with a little bit of an architecture backstory. This may feel like a little bit of an esoteric talk, but there's a reason for it. So we'll talk through that. Then we will talk through some of the Flink internals that makes this interesting. We will also do a 5-minute show and tell, Avinash. Okay, 5 minutes. Okay, and we will, there's a surprise in the end. So, all right. So what's the story, right? If you look at the traditional model of how data is managed inside any organization, you've got databases and the systems that you use for running whatever business you are in. So that is operational data, right? And then you've got a department of data somewhere in your organization. That's kind of your analytical data estate, which is where data traditionally lives in buckets. Here it lives in boxes. Here it lives in buckets. That's the simplest worldview of this world. But there is plumbing in between. That is, the data engineering. Okay? And that comes in two flavors, as everybody would know. So, you're going to potentially move batches of data from the operational estate to the analytical estate, potentially analyze it in whatever systems you might have. You might go run Spark clusters, go put data into a data warehouse, could be a Snowflake, run jobs in Spark. But that is one worldview of how you process data, which is batch oriented. So therefore, you're looking at a bounded amount of data. You know exactly how much data you're processing, what will come out of it. It is fairly deterministic in nature. Of course, we are in a Streams Meetup. So the second flavor is obviously you have continuous data exchange, or more specifically, you have some kind of data ingest going on. So you're ingesting data from databases, or your applications are sending events straight into Kafka, and then that goes over into the analytical side and stuff happens out there. So that's the second worldview. I think these worldviews are pretty adjacent to each other and they intersect somewhere. But largely, and you might observe this in many of your own organizations, there is a separate analytics team and there are separate people who take care of databases on the operational side. So these two are two distinct organizations, two distinct worldviews, different types of data stores. Fundamentally, they deal with different problems. Except in recent times, right, there is, a lot of convergence. In fact, it is, at some level, it is even difficult to say what the heck is operational data, what the heck is analytical data. So for example, if, you're running, a SaaS offering of some kind, you're going to use a machine learning model based on what a user is doing presently to generate an insight and basically go ship it back to the, the app or the website or wherever your users are interacting. So the whole flow that took place, right, is that technically in the operational estate? Is it part of doing business, or is it part of, analytics and the business of generating insights? Real answer is it is both, right? And this is something that many of us would deal with day in and day out. That is, data moves not only from left to right, from the operational plane to the analytical plane, but there is also a lot of exchange from the other side where data comes back. That could be as a result of ML models or just real-time data processing in general. So the buckets and the boxes intersect, There is a lot of pipelines, plumbing in between. You have taps. This is what the new data architecture really looks like. And that's kind of where, we have Kafka, Flink, stream processing. This is kind of this domain where we are in the business of plumbing, but also working with data as and when it is moving, data in flight, data in motion. So if stream processing fundamentally works on data in motion, so therefore it is perennially in transit. So in this worldview, right, of operational data versus analytical data, where exactly does stream processing lie is a little bit of a philosophical and architecture question. The answer is it probably is in both, right? It just depends on, your business and, the context boundary of what you're doing, right? So in specifically event-driven architectures, whatever you're doing with, a bunch of events, potentially computing an aggregate and saying, what's the state of this user based on, doing event sourcing or CQRS or whatever, that's pretty much in the operational estate. But, if you're ingesting all that data into an RTO lab database or running a stream processing job with Spark streaming or whatever, mainly to generate an insight out of it on the analytical side of things, which has no immediate business consequence, then that is in the analytical plane. But long story short, right? One worldview to think about, and I would actually encourage you to read this book. It's still raw and unedited, but I think it is about to be released. Hubert and Ralph are good friends of mine as well. About streaming databases, which talks not only about streaming databases, but also what this whole worldview of streaming is about. Where does it lie? One of the ideas it brings forth, and I will let you judge for yourself how that is relevant to what you do, is about the so-called streaming data plane. That is, basically the state of the data as and when it is in transit and potentially being processed. So I think that has a different sort of context implication in itself. And how do you use that data, right, is one of the things that you need to think about. The one insight that I can tell you is that most stream processing systems basically are not something that you can talk to directly. So stream processing is essentially about processing streams of data as they come and putting the results of that computation into another data store. The reason for that is simple. In the streaming world, what consistency even means is very different from what it means, the implications that it has in the database world. So there are many aspects of stream temporality, mainly because you can't hold an infinite amount of state in a stream processor. So nobody has an unlimited amount of memory, right? So there are aspects of consistency. Temporality, which is what I'm talking about, is, it's an unbounded amount of time, unbounded amount of data, but with, a time domain aspect to it. Are you processing this at wall clock time, or are you processing this based on event time? So there are different notions of time, there are different notions of space, and as a result, there are different notions of consistency. So traditionally, you would never talk to the stream processing system directly, right? The stream processing system would do what it does and basically put the results into a sink, which is where you would basically go pick it up. And that's the streaming data plane, right? The streaming data plane is not something you talk to, it talks to you. But this talk is actually about certain patterns that have evolved in not so recent times. For example, a lot of people have actually challenged that idea. Why not talk to the stream processing system, right? Why do you need another hop in between? The stream processing system does some processing, but it has to put it into, some other data store on the sink side before you get hold of that data, right? And the answer to that is, you can basically talk to the state backend, which is usually, directly in memory, or it could be an embedded database like RocksDB, etc., which is what most stream processing systems use. What if you could talk to the state directly? Because that's basically where, the state of your computation actually is, right? And that is actually a strangely popular pattern. If anybody has used Kafka Streams, I know the share chat team was talking about their extensive use of Kafka Streams. But one of the nicest features, in my opinion, of Kafka Streams is being able to interactively query and talk to state stores. So it's remarkably simple. You have a bunch of RPCs, you know where a particular key is. So therefore, you can go talk to the state store. And essentially, what you have as a result of that is you have a distributed database, right? Which can be purpose built technically for your unique use cases. And therefore, the result of all of that is you can do a ton of optimizations instead of using a stock database. So Kafka Streams actually has a lot of industrial use cases, mainly as an embedded, let's say embedded in your application. It is still distributed. It's a distributed database, right? For supporting various sorts of use cases without having to resort to, let's say, a Redis or a Memcached or something of that sort. So while this pattern is present with Kafka Streams, largely, it is actually restricted. Not a lot of people do it. So this talk, we will explore how do you achieve that in Flink. And there are a number of reasons why you would want to achieve this in Flink. So the question is why, right? If Kafka Streams does this, why would you even want to do this in Flink? The reason for that is very simple. Flink has a number of features which Kafka Streams doesn't. Okay, what are some of those? First of all, you have resource management. In Kafka Streams, there is basically no resource management. It's a library which basically coordinates itself and does task distribution. In Flink, you have that as a first-class concern. How do you do resource management? There are many other features that Kafka Streams also lacks, which makes it very difficult to use in specific scenarios involving quote-unquote consistency. So in other words, for many consistency and particularly disaster recovery concerns, you also need checkpointing, also known as snapshotting, save points, amongst other things. So Flink has many of these features, which are actually, in my opinion, feature gaps. In fact, design gaps with Kafka Streams. And it is also a comprehensive suite. It's not just about streaming alone. It's about batch as a subset of streaming. So therefore, it is unified data processing, both streaming and batch. And Flink also has a first-class application mode. You can say that's extremely heavy to embed Flink directly into your applications, but it's possible, as we will see through this talk. Lastly, Flink is also an extremely popular project. In fact, it is the most popular Apache Foundation project over the last 3-4 years. And it is basically in the same league as Kafka, where Kafka used to be about 4 years ago, Flink is there presently. So therefore, if you treat Kafka as the de facto standard of streaming and data exchange, you will invariably be compelled to look at Flink as the de facto standard of you do stream processing. So it's an interesting idea. How do you do interactive state stores? How do you talk to the state directly, which is possible in Kafka Streams, but how do you do this in Flink? So we will come and talk about how this is done. Original idea was to finish all the talking and then do a demo. But given the paucity of time, let us do a quick demo. Let's actually show how this works. Hopefully a demo is worth 1,000 slides. But let's do the demo and then let's come back and explore a few of the internals for another 5 minutes and then we'll take some Q&A. I'm sorry?
Right. I'm going to briefly demonstrate a quick POC that we've built to show how do you query a state store in Flink. So I'll just quickly walk through the setup that I have. That's a simple setup with a Kafka broker, which is running in KRF mode. So it's just Kafka cluster for source and sink. I have a producer that produces some data. For some context, the data is about the household voltage utilization. So I'm just calculating the average min and max voltage for a particular household. And I've Flink job manager, task manager. And this particular Flink job manager and task manager has a custom Flink image, which has a jar file that you need to be able to query the state store. That's the only customization. I have a container to actually submit the job and a container that has a serving layer for querying the state store. So that I have the broker and the uh, Flink manager, Flink cluster up. I'll bring up the producer, which will produce some data now, and now submit the job.
May the demo gods shine. Usually, usually demos never work on the stage.
And in order to query the state store, we also need the job ID. That's how the querying client will be able to identify which job state store to query for. So in order to get that, I'll just look at the logs for the submit container, which should have the job ID, and update this in my querying client. And bring up the query client, which has a RESTful interface to actually go query the state store per key. Okay, quick check to see if everything's running. Okay, looks like everything's running. So this means maybe I'll just show the UI as well to see the job is running. And yeah, we have a job running that calculates the average voltage. In the interest of time, I'll just skip showing the data and how the data looks like and all of that. But I have a HTTP interface for the query client, which can query the any particular key. So in this case, the state store has a key for the household. That is, for each household, it computes the average min and max voltage over a period of time. So I can query for any particular household. So this is querying the Flink state store internally and just returning the average voltage, min voltage, and max voltage. And the same thing for the other household. I just have two households here. So as I keep querying it, the value changes because it's constantly computing it. Maybe I'll just quickly show what the state store actually contains. So in the state store, I'm just storing four values. One of them is the total sum of the voltage, and another is the count of the number of entries that we've seen so far, and the min and max. So in the client, I'll quickly show the client as well. I'll share the source code in a GitHub repository. That would make more sense to just browse, but show the query client as well. So in the query client, I'm querying a state store with a particular name. So this is the same name that I've used in the Flink job. I did not show that, but I'm querying for a tuple of four values. That is the total sum of voltage, the count, and the min and max. And here for the average, I'm just computing the total by the count, and just the other two are displayed as is. So it's a very simple proof of concept to demonstrate that we can query the state store for any particular queue, for any particular key. So with that, I'll hand it over back to Pawan.
RocksDB.
Roxy.
It's RocksDB. It is persistent.
It is persistent, and it can be on S3 or anywhere. It depends on where you store.
Okay, so what did we just do, right? We ran a Flink job, which took a voltage stream, computed min, max, average out of it. We did not actually sync that anywhere, right? So it's basically still residing in Flink, and we queried it, in fact, with a HTTP interface. That is not built in, but we wrote a HTTP wrapper around it. How did all of this work, right? The point is, it actually works at the intersection of like three different subsystems. So you have a queryable state client, okay, which is basically talking to two server side components, which is the queryable state client proxy, which is responsible for talking to the job manager and understanding where is the key that I want to query. Know that Flink is a distributed system, so you have a number of task managers. So therefore, the job manager does the bookkeeping of where a particular key group lies and which task slot is it scheduled to. So in other words, if I'm doing some kind of stateful aggregation, there is a key. I mean, Flink looks at everything basically in terms of keys and key groups. Key groups are the most atomic unit of scheduling as far as Flink goes. So we talk to the queryable state client proxy, which talks to the job manager. Job manager retrieves from its bookkeeping which task manager is that key in. So we get a task manager as a result, and then the queryable state client proxy talks to the queryable state server, right, to ask what is the value of the aggregation that we are doing. The result of all of this is we didn't sync the data anywhere. We queried the data straight out of Flink. So in pretty much cricket terms, that would be like Surya Kumar Yadav's catch. Take the catch and come back. Bad example, but some quick aspects. Will not dive too deep into the nerdy details, but feel free to talk to us. How this works is, basically in Kafka Streams, this is a little more straightforward, but in Flinkland, you'll have to either instantiate a queryable state stream, which is a convenience object, or, against a managed key state, you'll have to set the state descriptor to be queryable. You can give it any name that you want, but this basically is an opt-in feature. You have to make the state store queryable. Once you have done that, you can then talk to it from your client, from your queryable state client. You're going to talk to, any task manager. That's the task manager host name. Any task manager will then talk to the job manager, as we said, and mediate the results for you. There are a number of aspects around this. What it actually returns is basically a completable future with, basically the state object holding all the stuff that you want. So the main gotcha here is the client is asynchronous. So you have to, if you want to clean up these resources, you have to call queryable state client shutdown to free up resources. Other important gotchas that you should know about, as we said, this is technically a solution around how do you look at Flink as a distributed database. So you should know that the state objects cannot be modified. Okay. So if you try and call an add method on it, you are going to get an unsupported operation exception. If you're querying a state object, there are concurrency issues that you should be aware of, especially if you're using the default state backend, which is the hash map state backend. Okay. But some of these patterns, basically your concurrency patterns are much safer if you use the embedded RocksDB state backend. It's safer generally from many of these issues, and it is also fault tolerant. Many of you might have this question. In fact, it's a good question to ask anywhere. Does this thing scale? Who else does this, right? So the short answer is yes, it will scale quite well. These are your tuning knobs. The tuning knobs are the number of network threads on the queryable state server side. Okay, and you have basically a separation of concerns between things that deal with requests, which are the network threads, and the actual query threads. So both of those are tunable as a function of the number of clients who you expect querying this. So you can basically scale pretty well. On the proxy side as well, the proxy is also on the server side. Again, you need to deal with requests, and therefore what you'll need to plan to scale is the event loop. Okay, number of network threads that are there to deal with those requests. So those requests also need to be forwarded to the upstream, which is the queryable state server. And therefore you have proxy query threads and you have state server, network, and query threads. These are your main tuning knobs as you scale out. So in fact, just in our own practice, we actually use this mainly to, with a couple of customers who are basically doing, let's say, WebSocket and HTTP push for a number of sleepy clients who are connected together. So therefore, the point is, this is very useful in terms of using Flink as a purpose-built database in the operational domain of things, but not just us. For example, you can look at this talk from Flink Forward in 2022. This is New Relic. So New Relic has SRE golden signals that they aggregate from a number of different services. How does that work? Is essentially many of these, I mean, the short use cases, it is a look-aside cache, which would otherwise be done in something like Redis, right? So in other words, New Relic has NRDB. So you basically go retrieve a bunch of signals from there. Now, what do you do with that? You can querying straight out of NRDB is going to be basically big O, and it's basically slow. So what they actually do with this is to look at Kafka as a golden signals buffer, right? And basically query everything straight out of the query store. Now, how does that really work out for them, and why this? Relative to using Redis for doing this solution actually works out 97% cheaper, right? At the scale that New Relic has, which is about 70.71 million golden metrics per minute. So it is a lot of scale, and it is a lot of very, very significant cost savings. So querying straight directly out of Flink, it works. It can be very useful in many scenarios. Where we find it extremely useful is basically a look-aside cache scenario, potentially gaming industry elsewhere, where you need to basically have, handle for many clients querying for, a bunch of different metrics, let's say. But there are other use cases apart from this. So that brings us to end of this talk. It's a little bit of an anticlimax because queryable state, the talk that we just gave about, is actually deprecated from Flink 1.19. Okay. So that looks like a very weird ending, but you can still use this in older versions of Flink if you would like. And I'm sure there's a lot of cyclicity in software. So many things go away and sometimes things come back. Who knows? Queryable state could be something on similar lines, but we'll come. We'll finish. You can still do this in Kafka Streams. So if not Flink, you can definitely look at Kafka Streams, where this is even more popular as a pattern. Is this worth it? Yes, I think we described it with a use case. This is going to be prone to shuffles. So, if you've got basically key groups being shuffled between different task managers, your state will move. All of these things are there. So you should probably, especially if you're exposing this to clients, you should probably have another cache layer on top of this. That's the use case that we actually spoke about. What many people might also want to explore is streaming databases. So streaming databases are also in the so-called streaming data plane. They also allow you to talk to them. But the main difference between streaming databases and a data flow oriented system like Flink is that in Flink, you control the data flow, whereas a streaming database is much more akin to a database, right? So that's much more about query planning and how do you go retrieve data out of a conventional B-tree oriented model, amongst other things. In Flink, you have a lot more control on how exactly data flows between the operators. If I were to do some predictions, I think in the following years, there might actually be a relapse of some of these stream processing capabilities actually built into databases. You can actually see that happening in, there are some databases, I don't know if anybody's heard of VoltDB and others. There are a lot of databases where some stream processing capabilities are actually embedded directly inside the database. The only thing is for UDF heavy stream processing, you need better UDF support, sandboxing, amongst other things. So think about it as an in-process Flink being built directly into the database. That almost sounds like materialized views. I mean, basically all streaming databases are actually, in fact, about materialized views. So I hope this talk was useful. There are a lot of Flink internals we can talk about. It is an extremely interesting area, but we'll open up for questions if there are any. We will restrict the questions mainly because everybody's hungry and I don't want to keep people waiting.
Maybe one like so we mentioned like queryable state is deprecated now, and I've also seen one feature announcement, sort of like not feature announcement, but so basically streaming databases. What I think of, like, for example, if I take an example of Rising Wave or something, they would give like ClickHouse or something, if I'm not wrong, or maybe Object Store behind the scene, and you can have a streaming data plane on top of it. One issue that I find with them is they don't give me a programmable interface. They would just give me a query layer or something.
They will give you UDFs.
So Rising Wave is giving you?
It gives you UDFs.
Okay.
The only thing is what languages can you write those UDFs in? That varies. Rising Wave supports Python.
I remember they would support something like maybe some small scripts or something, but I don't know anyways. But
basically you have three classes of UDFs. You have, Scala UDFs, which is basically stateless UDFs.
Yeah.
And then you have, stateful.
So UDFs is the scope that they will provide you. In the SQL queries, you can maybe use UDFs as well for your logics, some small logics or something.
And just in Flink land, you also have stateful functions, which is another way to, basically build similar stream processing capabilities into what are serverless applications.
Yeah. The question is that, with Flink, even if you are using RocksDB or something, the main advantage that would come with a streaming database is you have the bigger historical context. You can have an entire database lying through it, and you can query through, say, years of data or something over whatever trend or whatever query is coming for you. With case of Flink, I cannot keep a very bigger state. It's on SSD and it is costly. One advancement that I have seen is that there is a new disaggregated state store, I think, for ST, Flip 423, if I remember correctly, which is in talks. Like, I think it is still in development, but
you can plug in a state store today. You can plug in Cassandra. Many people have done it. There is RocksDB. If you look at Rockset, recent acquisition, Rockset already supports RocksDB directly on top of S3. That happens. The only thing is latency. What is the cost that you pay?
So with S3, I think it becomes quite slow, if I remember correctly, because there is JNI translation again 2 times, I think. But anyways, the question was more like, since it is getting deprecated, is it getting deprecated because now Flink is already coming up with its own disaggregated state store, maybe with some object store or something, and maybe that becomes queryable, and you have a direct database which you can query, and you don't have to go through the workers or something for that particular query part.
Yeah, there are a lot of things happening there. So Flink has its own what do you call it? We have Paimon, which is Flink's own table format.
Yeah.
Okay. And what you also see is just on the Kafka layer. So you have, I don't know if you've been to the recent like advancements on the Confluent side. So there's
Yeah,
stable flow.
they are
which can-
also Iceberg compatible. They're making their
Iceberg
tiered
compatible.
storage.
Yeah, basically tiered storage now spills over to, an iceberg table. So
Yeah.
therefore, you can now, write to the iceberg table with the Kafka protocol, but you should also be able to query it back. There are a lot of concerns around this, and maybe it is quite interesting. The only thing is Iceberg is not really meant for streaming workloads, at least at this point. Hoodie is a much better format. Flink has its own table store, which is Paimon.
Yeah.
So I think there will be a larger sort of convergence of all these technologies. Specifically, what you were talking about, historical data, I think that is much better served using something like ClickHouse or Druid, etc., rather than a streaming database. A streaming database is fundamentally acting on real-time data. So to use it to also query historicals is going to be a fundamental overreach of what streaming databases and stream processing engines do. You might always have broadcast style patterns of basically, getting historical context from something that's already pre-processed and using that to potentially roll up or enrich your, what's actually hot right now. That is a much better pattern in stream processing land. Or merging historicals into this thing, I don't think a silver bullet solution exists right now.
Okay, cool. And apart from that, one more question that I had was, you mentioned that queryable state on RocksDB, we have to opt in, like maybe a separate config or something. By default, it might not allow you to query.
It doesn't. Yeah, you have to.
So is
turn
there
this-
some performance implication also which is applicable to it, because of which it do not by default allow you to query?
I mean, RocksDB will allow you to query. I mean, the point is,
Maybe it is managing some more metadata or something to
yeah,
make it queryable.
There's some more bookkeeping. On the Flink side, you need to add a bunch of jars,
Oh.
both on the server side as well as on the query client side to make all of this work. So this does not work out of the box. First, you have to add the additional query server runtime capabilities, both on the server and on the client, then turn it on and then make the state store queryable.
Okay, thank you.
So I think one big issue with having queryable state store is like you're basically combining a throughput, something which is like optimized for throughput, I would say Flink, with something which should be optimized for latency. Like your read and your write path are probably optimized for different things. Like I have, whenever I think about this thing, like why should we have query versus should not have, there are two things that come to my mind. Number one is there should be a separation of concern here, where let's say any deployment you do in your write path should not affect your read path. If there's a separate database where you do like put those things in, you can scale those things separately. For example, today, I'm not sure like what level of concurrency this can support. Maybe it can support 1 million requests per second, but you have to build those things out. Like RocksDB is a very simple embedded data store. What Cockroach had done on RocksDB, now they have changed to Pebble, but what they had done on RocksDB is like many years of engineering to build what Cockroach was at that point of time, or what someone else has done. So do you still think like with all of these things, like isn't it like just simpler to have a separate like write and a read, like just do stream processing here, do the transformations, put it into a database, read from a database, because it just works. Like you don't have to worry about things. You don't have to worry about getting paged at the night. Okay, I did a deployment for my Flink and it is increasing latency for my read path, I would say.
I agree with you. This is not for the faint-hearted, but so I mean, look at the New Relic use case. I mean, you can do this. You can go put all of this big data into a huge Redis buffer, okay? But it's not a free lunch. Okay, so that's the point. I mean, do you want to incur the, the latency cost of that additional hop, syncing data through to some system? And secondly, the potential storage costs and the complexity of the additional system, which is probably the most commonsensical thing to do. For most use cases, you're probably good, right? But there are a subset of use cases where you can look at Flink as a purpose-built distributed database. That is basically what this talk is about. You can do Kafka streams for achieving the same result. The only thing is it obviously comes at a trade-off. That is what you spoke about. How do I support 1 million concurrent clients with this solution? You have to build it out. So as I said, there has to be a good, cost and benefit trade-off for doing anything of this sort.
Maybe you can just have an like best of both worlds, like use external state store for storing your own state, and then someone can query the external state store. The issue would be the impedance mismatch. Like Flink would expect state to be in a certain way, so you have to build a tooling to access that. Like as you said, like you can substitute the state store with Cassandra and then query Cassandra state store, but then you have to have that impedance mismatch. Like the data model there would be what Flink expects. Like you cannot change it, I would say, right?
Yeah, the reason why all stream processing systems they want to do basically local operations. That's basically why you have RocksDB. That it's an unreasonably effective solution. Can you make RocksDB spill out with nice POSIX APIs directly into object store? Yes. But the only thing is there is a network hop there and it comes at a cost. So I think the fundamental thing is, should you have local state stores at all? So if you look at streaming databases, they don't have local state stores at all, right? So the Kafka Streams model is also to write to local state stores, but also backed up by a changelog. So the only point about these things is the trade-off between, your recovery time objective, latency, and the cost of external systems. Those are the 3 considerations to make.
Yeah, I think I agree. So there's like one startup which is doing very interesting things here, like Responsive, who have entirely gone like local is just a cache on top of things. Maybe they have figured out some things. It's a difficult thing to figure out, honestly. Yeah.
Responsive is doing very interesting things. Yeah, but there are many things about Kafka streams that are still broken. For example, the lack of snapshotting, checkpointing. Also, how do you deal with failures? The way you deal with failures in Kafka streams is to have standby replicas. So some of these things are not big safety nets. We should have a longer extended discussion about this, of course. But yeah, I mean, Responsive is doing very interesting things in the Kafka stream space. Any more? Yeah. Thank you, everybody.